Game time. Is that counter going up there? Yes. Is that counting? Okay. Here's your UT homework. I'm going to go over the problems here. I won't necessarily do all the work for all of them, but I'll at least get you started in the right direction. So first video we'll go through 1 through 8, and then I'll break it apart into a second video for 9 through the rest of the assignment. So number 1, this is very simple. I've got the correct answers here on mine. Obviously your assignment won't show that, but a flute is an open-ended pipe. That means double open-ended. So really, we've got the fundamental here, and the second harmonic is just double that. So you can see the answer is 610. All right, and I think that takes us through 1 through 3. Pretty simple. Just testing if you know how to double and triple and all that stuff. Okay, now to something a little bit more challenging here. Here we've got a standing wave on a string, and we've got the frequency, so we can say F equals 8.11 hertz. And we've got the string length, okay? So we got to think about what harmonic that is. And all we have to do for strings is count the loops. So this is the second harmonic. And relating the second harmonic to wavelength is very easy. So how much of a wave are we looking at here? We got a half lambda there. We got a half lambda there. So we got full wavelength. So length for the second harmonic is equal to lambda. All right, only for the second harmonic though. Okay, so in other words, the wavelength is the length of the string, or 2.6 meters. Okay, and we've got those nodes and all that. Find the speed at which the waves propagate. So all we have to do is V equals F times lambda. I'll let you guys complete it from there. That would be the answer for me right there. All right, next part. Find the fundamental frequency of the string. Okay, so we decided that this was called F2 right here, 8.11. So we know that F2 is equal to 2 F1s. And then all we have to do is divide to get to the fundamental. And I'll let you take it from there on that. Okay, lowest note on an organ. Number 6. Okay, so stuff that we know. We've got a frequency F equal to 29 hertz. And we want to know the shortest pipe with both open ends that will resonate at this frequency. And we've got V. So let's say V equals 343. Okay, so let's draw this. We need to be really good at analyzing and drawing these pictures. So the shortest pipe that will resonate at this frequency. Alright, well, that's going to be the first harmonic. So we're going to draw the first harmonic. And for the open-ended series, looks like that. Like that. Okay, and this will become a little bit more important here in a second. But how much of a wave are we looking at right there? That's what we got to figure out here. So using these, we can get lambda. So V equals F lambda, or lambda is equal to velocity over frequency. And we can say lambda equals 343 over 29. Okay, and if I do that, 343 divided by 29, I get 11.8. So lambda is equal to 11.8 meters. But this right here is, for the fundamental, only half of a wave. So I don't need the pipe to be that long. I only need half of that. So then I'm just going to divide this by 2. Okay, and that's not going to be lambda anymore, it's going to be pipe length. So L is equal to 1/2 of lambda, in other words, for the fundamental, which is going to be the shortest pipe. So then half of 11.8, 5.91, that looks good. Okay, I'm not even going to plug it in. Don't laugh. I have a student in here making fun of me while I make this video. What would be the lowest resonating frequency of the same organ pipe if we close one end and leave the other open? Okay, now some stuff from here still applies. So first of all, let's draw what that looks like. So here is our single open, single closed pipe. And we want F this time. So we want the lowest resonating frequency. In other words, we want F1. Okay, and we already know the pipe length. So the pipe length is our answer from up here. So L equals 5.91379. Okay, that's the full unrounded answer. So that's in meters. And then let's draw the wave in here as well. So for the fundamental, it looks like that. Okay, and relating this to lambda. Okay, so for closed-ended pipes, our notes say that the length of the pipe is equal to 1/4 of a wave here. I'm recording a video, so I can't really talk right now, Cole. Sorry. Okay, so we know length, so let's plug that in right here. 5.91379 equals 1/4 of a wave. And if I multiply, I get the wavelength. So let's do that. And I get 23 and change, so lambda equals 23.655. I'll leave a few decimals. And that's meters. So that would be the full wave. But there's only a quarter wave in the pipe. So there you go. There's lambda. All right, now if I've got lambda and I've got the velocity, which I do, velocity is still 343. If I've got both of those, then I can get the frequency, which is going to be F1. So V equals F lambda. F is equal to V over lambda. All right, and I'm going to do 343 over 23.655 and change. Okay, so let's divide that. 343 divided by 23.655, and I get 14.5 hertz in the calculator. A couple zeros after it, and that's the same answer as up here. Okay, so that should take us, well, let's put one more on this video. Let's do this problem. Standing waves 09. Okay, so we've got a wire, so it's kind of like this problem down here. Same set of harmonics, and we've got the length and the speed. What's the minimum frequency she should apply to set up standing waves? So the minimum frequency is the longest wavelength. And the longest wavelength is the first harmonic. So we're dealing with F1 here to start. All right, and we've got this string like we've drawn in our notes a bunch of times. And we know that L equals 1.4, V equals 600. All right. We want to find this, okay? But we can't do V equals F lambda yet, because this is not the wavelength. That's just the length of the thing. So it's going to look like this for F1. It's going to be a torpedo football shape, one loop. And we know that this is 1/2 of a wave. So we can say that L equals half lambda. Or lambda equals 2L. Okay, so now it's pretty easy from here. Lambda equals 2 times 1.4 equals 2.8 meters. And now I've got my wavelength and I've got my speed. So I can find the frequency. Frequency is equal to V over lambda, or equal to 600 over 2.8. And let's make sure that's right. Okay, so 600 divided by 2.8. And we get 214, which is the answer right there. Okay, so I hope that helps, and the rest of the assignment I'll do in the next video. Alright, thanks for watching.